In this session, so we're going to solve the exam paper for MAT1120, basically 2021 exam paper. So these are the questions. So question 1, question 2. So these are the questions for 2021. However, in this video, we're just going to solve question 1 and question number 2. Then the other ones, we're going to solve them in later sessions. So basically, this is our question 1. And we're going to solve all these questions on question number 1. Then we're going to solve also question number 2. Okay. However, we're going to continue solving all these questions because all of them have been separated until to the last question, so that we're able to follow through. Okay, now let's start with the first question. So question number 1, we're told to write 2.517 in the form a over b, where b is not equals to 0 and a, b are members of integers or are integers. So basically, if a number can be expressed in the form of a over b, we know that this is a rational number. Okay, so basically that is the information that we know. Now we have 2.517 and 17 is repeating. Okay, now you know that rational numbers are numbers that can be expressed in the form of a over b. For an example, if I get 1 over 2, if I'm dividing, I'm just going to get 0.5. Now this is what it means. It means that even if we want, we can put zeros, 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 and we'll be going like that. The zeros in this case will be repeating, or if we want to just end at 0.5, which is still the same. So even in this, if this number, the 17, is repeating itself, that is also a rational number or a fraction in simpler terms. So now how do we prove, or how do we solve these rational numbers? So we're going to let a to be equals to, let's say, the same number, 2.517 repeating. Okay, now that we've let a to be that, allow me to now multiply by 10 on both sides. Why am I multiplying by 10? Because we want this point to move one step forward like that. So basically that's what we're going to do. So I'm going to multiply on both sides by 10. Okay, so allow me to call this one as my left hand side, then allow me to call this one as my right hand side. Okay, now if I multiply by 10 on both sides, on my left hand side I'm going to have 10a. When I come to the other side, the point is just going to move once, so I'm going to have 25.17 repeating. Now that I've got this, I'm going to again multiply by 100. Why I'm doing that is because I want the point to move 2 times now. 1, 2. That's where I want my point to be. Therefore, I'm going to multiply by 100 on both sides. Now, on my left hand side, when I multiply by 100, I'm going to have 1000a. So, when I come to my right hand side, the point is going to move 2 times. Therefore, I'm going to have 2517.17 repeating. Now, what I'm going to do is that I'm going to name this one as equation number 1, this one as equation number 2. Then what we're going to do is that we're going to subtract equation number 2 minus equation 1. Okay, so I'm going to start with my left hand side. So if I subtract 1000 a minus 10a, what am I going to get on my left hand side? Then I come also to the right hand side. If I subtract 2517.17 repeating minus 25.17 repeating. Okay, now 1000 on my left hand side minus 10a, that gives me 990a. this will be equals to, on the other side, if I subtract 2517 minus 25, because these ones are just going to give me 0 at the end, so minus 25, what am I getting? On this one I'm going to use a calculator, so I'm getting 2492. So basically that's my answer on my right hand side. Now let me now divide the two. Allow me to wrap just this part. Okay, so what we have now is 990a, this is equals to 2492. Then I'm going to divide by 990 on both sides. Okay, basically this. Therefore my a will be equals to 2492 over 990. Now this is our answer. However, you can, if you want, you can simplify it further, where you are dividing maybe by 3, but if it's not, can be simplified any further, even this is just the final answer. Okay, then you can also try out dividing this same number divided by 990. It should give you this as our answer. So basically that's how we're going to, that's what will be our final answer in this case. So we've expressed it in the form a over b, a fraction. Yeah, we've expressed it in this form, a over b, which is a fraction. This is also a fraction. So basically that's how you're going to solve question number 1. Now when you come to question number 2, we've been given that z is 3 plus I over 1 minus I. Find z minus 1 over z, giving the answer in the form a plus ib, where a and b are real numbers. Now what are we talking about here? You know that we're talking about complex numbers, right? A plus ib. So the a and the b, these are the real numbers that they're talking about. However, the I in this case, we're talking about the imaginary part, or the image of a. So basically that. So these are big numbers. Okay, so now that we've got this as a guide, and they want us our answer to be in that form, so we're trying to solve z minus 1 over z. Okay, basically what I'm going to do, I'm going to find what z is, and I'm going to find what 1 over z is, then I just subtract the two. So let me start with z. Now z, we've been given that z is equals to 3 plus I over 1 minus I. Okay, so now what I'm going to do now is, you know that I'm going to subtract, I'm going to multiply by the conjugate of the denominator. Okay, so in this case the conjugate should be like the opposite, which will be 1 plus I. Okay, so I'm going to multiply this one on both sides. Okay, so now what am I going to have when I multiply on top? So what it means that on top I'm multiplying this and that. Okay, now this means that the 3 is going to multiply with everything that is in the bracket. We find our answer. Then the I is going to multiply with everything that is in the bracket. We also find our answer. So let's start with the 3. The 3 multiplied by the 1, I'm going to have a 3 plus the 3 multiplied by the I is going to give me 3i. Okay, now that I've got this, now I'm going to come to the I. The I now multiply with everything that is in the bracket. Now I multiplied by 1, that will just be I. Then I multiplied by the other I, I'm going to have I squared, so plus I squared. So allow me to just rub this part. Okay, basically that is what I have on top, divided by, I'm dividing this by, now this that I have down, this one and this one, they're also multiplying. However, if you're able to see, this is a difference of 2 squares. So if I've got a, let me say a minus b, okay, then this is squared. Okay, so this can also be the same as a squared minus b squared, or just, you know, a minus b, a plus b. Okay, basically that. So even me, since this is a difference of two squares, I'm just going to get the one that has a minus, and I'm just going to square each of them. So therefore I'm going to have 1 squared minus I squared. Okay, basically this is what I have. Now let me solve on top. On top, when I solve, I've got 3 plus 3i plus I, that will just give me 4i. Now I squared just gives me a negative 1. Okay, so therefore I'm going to have a negative 1 over, when I come down, I've got 1 squared. 1 squared is just 1 minus, then I've got another I squared. I squared, we're saying it's negative 1. So this is what we have. Now when I solve on top, 3, there's the common ones that we have. We've got 3 and negative 1. These are common, or let me say they are similar. They are like terms in that case. So 3 minus 1, that will give me a 2 plus 4i over. When I come down, you know that this is a minus, and the minus, they're multiplying, they'll give me a plus. So it will be 1 plus 1, that will give me a 2. Now what I'm going to do now here, I'm going to separate. So I'm going to have 2 over 2 plus 4i over 2. Okay, I've just separated the denominator. Now when I do that, what am I now going to have? 2 over 2, that is just a 1, plus 4i over 2, that just gives me a 2i. Okay, a 2i. So basically that is what I have as my z. So z, therefore z, I'm saying z is equals to 1 plus 2i. Okay, now that I've found my z, let me find my 1 over z. Okay, so there are different ways of solving this question. However, even this one is also a recommended one. Let's now solve z, 1 over z. Now you know that 1 over z is just the same as 1 over, what have we been given as our z? Let me just write it somewhere here. Allow me to wrap this. We've already found our z. Okay, so now we're finding 1 over z. Okay, that is 1 over what is our z. We're just from finding what z is, which is this. Okay, so this was z, but we simplified it to this. Okay, so I'm just going to replace where that, so I'm going to put 1 plus 2i. Then we're just going to do the same like we did. We're going to multiply by the conjugate on both sides. So I'm going to have 1 plus 2i, 1 minus actually the conjugate, 1 minus 2i, also 1 minus 2i. Okay, that's what we're going to do. Now when I multiply this one, multiply by that, I'm just going to have 1 minus 2i on top over. Then what I have down is the difference of two squares, like we said. So I have 1 squared minus 2i, this is squared. Okay, now if I solve on top, 1 minus 2i, it will just be the way it is. When I come down, 1 squared is just a 1 minus, okay, this square, the square is on 2 and the square is on I. Now if I find 2 squared, that will give me a 4. Then the I squared is going to give me a negative 1. So basically I'm going to have 1 over 2i on top over 1 plus 4. Okay, because 4 multiplied by 1, that is 1. There's a negative and a negative, they'll give us a positive. So basically what I have now is 1 over 2i over 5. Then I'm going to separate like the previous one. I'm going to have 1 over 5 minus 2i over 5. Okay, so basically this is what I have as my 1 over z. Okay, So we found 1 over z. Okay, so 1 over z, we found that it is 1 over 5 minus 2I over 5. Okay, so this is what I have. Now let's now solve. So our question is z minus 1 over z. Okay, now we found that z is 1 plus 2I. Then we're subtracting by 1 over z. 1 over z, we found that it is 1 over 5 minus 2I over 5. Okay, that is what we have. Now from here, what am I supposed to do? Let me first distribute the negative. So I'm going to have 1 plus 2I. Now I'm going to have negative 1 over 5. Now there's a negative here and the negative. These ones are going to give us a positive. So I'm going to have a positive 2I over 5. Okay, basically this is what we have. Then from here we're going to put the like terms together. Okay, so I have 1 minus 1 over 5. Okay, plus I'm going to have 2I plus 2I over 5 on the other side. Okay, basically this is what we have. Now let me just represent by different color. Here I'm going to say 1 over 1, even here over 1. Then I'm going to find, here I'm going to find the common denominator, which is 5. Okay, so 1 into 5 is 5. 5 multiplied by 1, that is a 5. Minus 1 into 5. 5 into 5 is 1. 1 multiplied by 1 is 1. Okay, that is what I'm going to have. Plus, when I come to the other side, the common denominator is still 5. So 1 into 5 is 5. 5 multiplied by 2I, that is 10I. Plus 5 into 5, that is 1. 1 multiplied by 2I, that is 2I. Okay, basically this is what I have. Now if I simplify it further, on top, if I write it on top, what I'm now going to have is 5 minus 1, that just gives me a 4. So I have a 4 over 5. Then there's a plus. Then 10I plus 2I, that gives me a 12I over 5. Okay, so basically this will be my final answer because it's already simplified in the form that they've asked us. They want it in the form of a plus ib, which we've done. This is the real part, this is the imaginary part. So basically this is how we solve the first this question. Okay, we come to the question on sets. We've been told that we let a to be that. Okay, so we've been given that a is equals to -2 to 2, b is from 0 to like 8 close, c is from -5 to 1 close. Okay, then we're trying to find a intersection b minus c. Okay, expressing your answer in interval notation. So want our answer in interval notation. Now you remember the difference law. The difference law was something like, if I've got a minus b, so according to the difference law is that I want a but I don't want b. So this is the same as a intersection b complement. Basically that. Okay, so even in this case, that's what we're going to do to make our work easier. Okay, so I'm going to also do the same. So this will be simplified to a intersection b intersection c complement. Okay, that is what we have basically. Now that we've got this and we've got all the information that we need, allow me now to use a number line to come up with our solution. So if this is our number line, okay, that is our number line. So from our number line, let's write a. A we're saying is from -2, let me put, let's say 2 is here. Okay, so we're moving from this -2 to the other -2. Now am I supposed to shade or not? apparently no, I'm not supposed to shade because these are not included, so I'm going to join them like that. So that is our A. Okay, now I come to B. B is from 0 to like 8. So if I put my 0, let me say 0 is here, and let's say we put our 8 there. Okay, so if I put this is 0, this is 8. Okay, so we are moving from 0 to 8. So if this is our B like that and I join it like that, now the question would be which one is included. So 0 is not included, it's open, but our 8 is included. Therefore, where there is 8, I'm going to shade. Okay, so here I'm going to shade because 8 is included. We are saying this is B. Now let me put C. C, we're saying it's from -5 to 1. So if I say my -5 is here, and I say my from -5 to 1, let's say 1 is somewhere here in between 1 and 0, 0 and 2. Okay, and if we're going to draw, if let's say it's from here to there, okay, that is what we have. Now if I'm going to join this, I'm going to join it like that. Now which one is included? We're able to see that 1 in this case is the one that is included, so I'm going to shade where 1 is. Okay, basically this is what I have. Now what sets do we have here? We've been given A intersection B. Okay, so that is easier to find, but we don't have C complement. So let's also indicate on our diagrams where C complement is going to lie. Okay, so allow me to use a blue color. So we're saying this is C, right? So C complement will be from here. I'm going to shade because 5 is not in C, meaning it's in C complement, so I'm shading, so we're going in that direction. This is one part of C complement. On the other side, we've got this other part, this part. Now this part, you're able to see that 1 is found in C, so it's going to it's not found in C complement, so C complement is going in the other direction as well. Okay, so basically this is what we have. Now we're supposed to find, our question is to find the intersection between A intersection B and the C complement. Now A intersection B, we know that it is this part. This part is between A and B. Okay, this is the only part that is between A and B. Now we're able to see that now if we were now to also include C, it means I'm supposed to rub, I also include C. Now C, you're able to see that it is from here to there, because this is also part of C complement. Okay, so if that is the case, that is the answer that we want. Now what will be now our final answer? So therefore A intersection B minus C will be equals to, now we're able to see that there is 1 and 2. Okay, so there is 1 to 2. Now are they included or not? Let's start with 1. 1 is found in C, it is found in B, but it is not found in C complement. Therefore 1 is not included. We come to 2. 2 is found in B, 2 is found in C, but 2 is not found in A, so 2 is also not included. So basically this is our final answer, expressing it in interval notation. So this is one method that you can use. The other method is you listing these numbers and trying to find what is not there. So basically you are going to use the formula that resonates best with you. Okay, so let's go to the next question. So we've been told to let f of x is equals to x squared minus 4x minus 5. Then we're told to sketch the graph of f of x. We're told to indicate all intercepts and turning points. Then question number Roman numeral 2, we're told, we're asked, is the function f of x even or odd or neither? Justify your answer. Then 3, we're told to find the values of x for which f of x is greater than 0. Okay, so let's just do that. So we're told to sketch. So basically, in this case, I'm going to use completing the square. Okay. Okay. So basically, completing the square helps us to find almost everything. That's why I've gone for completing the square. Okay, that's why I've gone for completing the square, because we want our answer to be in the form of a x plus p squared plus q. That's how we want, because what this signifies is that our p and our q will be able to give us a turning point. Okay, so and now we can solve. So we've got f of x is equals to x squared minus 4x minus 5. Now when you're solving using completing the square, you have to half the coefficient of b and you square it. Now the coefficient of b in this case is -4, and if I half that, it means I'm just dividing by 2, which will give me a -2. So this -2 that we have to square it and we have to subtract it. Okay, so -2, it has to be squared, and we are going to again subtract -2. That's what I mean. So basically that's what we're going to do. So I'm going to have f of x will be equals to, I'm going to have x squared minus, let me just write my 4x first. Then we're saying I'm going to have minus 2 minus 2. Okay, it's fine. You can even do it like plus minus 2 squared minus again minus 2 squared minus 5. Okay, basically that. Now what I have now is that I'm going to ignore the one that we've halved. Okay, then I'm going to ignore the one that we've halved. However, the ones that this one and this one are squared, so I'm going to put them in one bracket. So therefore my f of x in this case will be equals to, I'm going to get my x minus 2, then I'm going to square this because they're squares. Therefore now I've got the minus here, then there is this part, -2 squared. Now -2 squared gives me a 4, okay, or a positive 4. Then there's a minus 5, so I'm supposed to write that minus 5. Okay, therefore my f of x in this case will be equals to x minus 2 squared minus 9. Okay, minus 4 minus 5, that gives us minus 9. Okay, basically this is what we have. Now for us to find us the turning point, because the question is asking us to find the turning point, so the turning point is given by -p, q. So in this case, this is our -2 is our p, then our q is -9. So in this case, since we have a negative and here we have a negative, we're just going to have a positive, right? So in this case, I'm going to have 2, -9 as our turning point, where the graph is turning from. Okay, now that we found our turning point, let's find the intercepts. The intercepts is where this graph is cutting the x and the y axis. Let's start with the y-intercept. Now on the y-intercept, we know that x is equals to 0. So if x is equals to 0, in the whole function, wherever there is x, I'm going to put a 0. So therefore I'm going to have f of 0 will be equals to 0 squared minus 4 0 minus 5. Okay, now 0 squared and 4 multiplied by 0 0, so I'm just going to have a negative 5. Therefore the y-axis is being cut at the point 0 comma negative 5. That is the y-intercept. Now let's find the x-intercept. X-intercept. Now on the x-intercept, we know that your y or your f of x is equals to 0. Okay, so our f of x is equals to 0 on the x-intercept, which is the same case like we were solving here. Okay, so if we solve, we're going to reach here where we reached. So basically that's what I'm going to do. I'm just going to replace here by 0. Okay, so 0 will be equals to x minus 2, this is squared, minus 9. Okay, now what I'm going to do is that I'm going to put the like terms together. The negative 9, I'm going to take it to the other side where 0 is, and when I do that, I'm going to have 9 is equals to x minus 2, this is squared. Now for me to remain with for me to cancel the square, I'm going to square root on both sides. So I square root this side and I square root that side. Now the square root of 9 is positive or minus 3. This will be equals to the square and the root are going to cancel this side. So I'm just going to remain with x minus 2. Therefore now for me to remain with x, I'm going to take the 2 to the other side, and I take the 2 to the other side. I'm going to have x is equals to 2, positive 2, positive or minus 3. Therefore my x now will be equals to 2 plus 3, that gives me a 5. Another value of x will be equals to 2 minus 3, that gives me a negative 1. So basically these are the 2 points where this graph is going to cut the x-axis. Now that we've got that, we can now sketch. Okay, we found all the intercepts, we found all this, the turning point. So basically we have everything that we need to sketch our graph. Okay, that is our turning point. Okay, so okay, so if we say this is our y-axis, and where can I put my, okay, let's say this is our x-axis. Okay, so if we've got that, let's put the numbers. We are saying the graph, the x-axis, this is the x and this is the y. The x-axis is being cut at negative 1. Let me say negative 1 is here, and at 5 is there. Now the y-axis is being cut at 0 comma negative 5. Let's say our negative 5 is somewhere here. Then our turning point is at 2 comma negative 9. So if I put my 2, let's say it's here, let me put negative 9, and negative 9 is maybe somewhere there. Let's put it like that, and our point is here. So basically let me just now indicate the points so that we join them nicely. So the graph is being cut here on the y-axis. Our turning point is there, and it's also cutting the x-axis there. So basically these are the points that we have. So our job would just be to join these points. So yeah, it's going to come like that, pass through that point, and it goes like that. So this is a graph of x squared minus 4x minus 5. So this is how you solve this question, basically that. Okay, now we come to the next question. The next question is asking us, is the function f of x even or odd or neither? Justify your answer. Okay, so we are trying to find if it's even, odd, or neither. Now you know that if a function is odd, we know that your f of negative x is equals to negative f of x. Okay, then if a function is even, what do we know? We know that if a function is even, f of negative x is equals to f of x. So basically these are the two equations. Now before we even solve, there's a clue that I always tell people. So before we even solve, you're able to predict whether a function is going to be even or odd by looking at the powers of x. So look at the power of x here. Here it's a 2 and here it's a 1. Here we can also put x to the power 0, right? Which would be a 0, okay? Because this has a power of 1. This, if we put 0 there, the powers of x are reducing from 2 to 1 to 0. Basically that's what it means. Now we're able to see that 2 is an even number, 1 is an odd number, 0 is an even number. So basically you cannot decide whether it's an even or odd because you have a combination. So it's neither even nor odd even before we solve it. Okay, so basically that is it. So that's how you can determine even before you solve. Now after stating that, let's solve. Let's first try to check if it's odd. Okay, so if it's odd, we're saying f of negative x will be equals to, what it means is that wherever there is x, we're going to be replacing negative x. So therefore I'm going to have negative x, this will be squared, minus 4 negative x minus 5. Basically that. Now negative x squared, that is just x squared. Negative 4 multiplied by negative x, that gives me positive 4x minus 5. So basically you're able to see that this is really different from that. Okay, so because it's different, it's not odd. Okay, so and the opposite is true, because if this is our f of x, this cannot be equals to f of x. So because this again is also not equals to f of x, which is that, because we've done that. You're able to see that it's not equals to f of x because f of x has minuses throughout, but this one has positive and the minus. It's not also equals to f of x, so it's also not even. So basically this function is neither odd, is it no? Okay, no even, or even, or something like that. So basically this is how you show that the function is odd, even, or neither. Then number 3, we are told to find the values of f of x for which f of x is greater than 0. Now f of x is our function. Our function, we're able to see that it is x squared minus 4x minus 5. We're saying this is greater than 0. Now greater than 0, it means we've upgraded. Now we're talking about inequalities. So because we've introduced the aspect of inequalities, we have to factorize this part. Okay, so basically that. So let's factorize. So let's try to use the product, the sum, and the factor method. Product, sum, and factor method. So the product is negative 5. The factors, or the sum, is negative 4. two numbers, when we multiply them, we're going to get a negative 5, but when you add them, they'll give us a negative 4. So basically that. So what do we have? So we can get a negative 5 and a positive 1. Okay, now that we've got this, it means I'm going to replace it where there is 4x. Okay, therefore I'm going to have x squared minus 5x plus x minus 5 is greater than 0. Okay, now that I've got that, I'm going to now factorize. I'm going to now divide my equation into two, this one and that one. Okay, then I'm going to factorize them individually. Now when I start with the first one, you know that x is common on both sides, so I'm going to have x outside, then I'm going to remain with x minus 5 plus, on the other side I can put a 1 outside, then I'm going to have x minus 5. This is greater than 0. Now that I've got that, since the x minus 5 is common, I'm just going to get one of them, then I'm going to put x and 1 together. So I'm going to have x plus 1 and x minus 5. This is greater than 0. Okay, now that I've got that, what are my critical points? My critical points are, I'm going to get each of them, then I equate it to 0. So if I get x minus 5, I equate it to 0, I'm supposed to find the answer. I'm also supposed to equate x plus 1 to be equals to 0. So therefore x in this case is going to be 5, the other one x to be equal to negative 1. So those are my critical points. Okay, now that I've got that, now I must make mention something here. There's also this x, so this x we can also just equate it to 0 because of the 0 there. Okay, so now that we've got this, we have everything we need to, you know, to determine the signs of these equations. So let me just do that. So here I'm going to put the equations, the range from okay, so this is our diagram. Okay, so let me put, these are the intervals that we have. Okay, so the intervals that we have, since we've got negative 1, so we can move from negative infinity to 1, from negative 1 to negative 5 to 5, then from 5 to infinity. So basically those are the intervals that we're going to have because of those critical points. So I'm saying from negative infinity to 1, that would be our first interval. Our next interval is from the same one, negative 1. Actually I'm saying this is negative 1. Okay, so from negative 1 to 5. Then our next interval now is from 5 to positive infinity. Those are our intervals. Then what are our equations? Our equations, we've got x minus 5. Another equation is x plus 1. Now the last one is the multiplication of them, which is, allow me to just put it, x minus 5. It means they are multiplying, the multiplication of signs now. Basically that. So let's start with the first interval. So for the first interval is from negative infinity to 1 to negative 1. So if we pick any number between negative infinity and negative 1 and we place it in the x minus 5, what are we going to have? So if I say this is x minus 5, if I get any number between negative infinity and negative 1, let me say I get negative 2, I'm going to have a negative answer. So basically here it is a negative. Okay, now between negative 1 and 5, if I pick any number, let me say a 2. If I put a 2 there, I'm still going to get a negative answer. So this would be a negative. Now between 5 and infinity, if I get 6, I'm going to have a positive number. So this is positive. We come to the next one, to the next equation. The next equation is 1 plus 1. Okay, let's start with the first interval. So between negative infinity and negative 1, we pick any number and we replace. Let me say I put negative 2 here. I'm going to have a negative answer. Okay, now if I pick a number between negative 1 and 5, let me say I pick a 2, I'm going to have a positive number. And if I pick any number greater than 5, I'm going to have still a positive. I'm going to have a positive answer. Now when I multiply the signs, that's what the last part talks about. You're multiplying the signs. Now if I multiply negative multiplied by negative, that gives me a positive. So I'm going to have a positive answer here. Negative multiplied by a positive, that will give me a negative. Positive multiplied by positive, that will give me a positive. Basically that. So now what will be our final answer? Because they want the values of x for that range. Okay, so therefore our answer will be equals to, now you're able to see that we want the values that are greater than 0. So always follow the inequality symbol. So it's telling you want the values of x for this function which are greater than 0. So it means we don't want negative numbers, because any number that is less than 0 is negative. So in this region we want the range, we want the positive and this positive. We're not getting this negative. Okay, so basically that's the range that we're going to get. And what is our range? In this case it is from negative infinity to negative 1. Then we're going to put union. Then we come to the other side. This is 5 to positive infinity. Those are the answers. When you put in the function, they are not going to give you a negative answer. So basically this is how you find the values of x and the critical point. So this is our final answer for this one. Okay, so let's solve another one. So we're told to solve the equation 2 sine sine to the power 3x minus sine x is equals to 0. Then they've given us a range. It's from x is between 0 and 2 pi. Pi, we know that is 180. 180 multiplied by 2, that is 360. So they want the values between x. The x values are between 0 and 360. Okay, so basically that. So now let's solve. So since we've been given 2 sine power 3x minus sine x is equals to 0, this is an equation. So we've been told to solve this equation. So how are we going to find the values of x? So allow me first to factorize this the sine x on both sides, because it's common. So I'm going to have sine x outside, then I'm going to this side, I'm going to remain with 2 sine squared x minus 1. This is equals to 0. Now that I've got this, what does this mean? I can separate the two equations. What this means is that sine x is equals to 0, then 2 sine squared x minus 1 is also equals to 0. So let me solve the 2 sine on the other side. Now if I solve this, what am I going to have? I'm going to have sine. Okay, let me just write it step by step. I'm going to have 2 sine squared x is equals to, I'm going to check the negative 1 to the other side. I'm going to have positive 1. Then I'm going to divide by 2 on both sides. So basically that. Then I'm going to square root on both sides. So for us to remove the square. Okay, so I'm going to now remain the square and the square and the root and the square are going to cancel. So I'm going to remain with sine x is equals to the square root of 1 over 2. Now what this means is that you're finding the square root of 1 and you're finding the square root of 2, which can be simplified as sine x now will be equals to the square root of 1 on top is just 1 over the square root of 2. So basically this. So these are our 2 answers that we have. Okay, now we found that sine x is equals to 0. Where else is it? If you punch sine x, where else is it also going to give you 0? We know that it is at 180. But now look at the range. The range has been given in terms of pi. 180 is the same as pi, right? So these are the 2 answers for the first answer. Okay. Then we come to the other side. We found that sine x is equals to 1 over 2. Now 1 over 2, okay, since this was a square, so this is positive or minus. Okay, let's not forget that. I forgot to put that. It is positive or minus. Okay, now according to our diagrams from our triangles, you know that this is it giving us, is it 30 or 45? So if this is our diagram, okay, so if these 2 values, these are 1 and 1, this is 2, this is of 90 degrees, this is 45 and that is 45. Then according to your SOHCAHTOA, you know that sine is equals to opposite over hypotenuse. So if we're getting this as the angle that you're trying to find, it is going to be opposite over hypotenuse. Now the hypotenuse here in this case is the square root of 2. So that is it. So this is 45. Okay. Okay. So sine x in this case is equals to 45. Now 45 is a positive answer. Where else is sine positive? So you go back to your diagram and we say all students take coffee. So all students take coffee. So in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine is positive. And in the second quadrant, you know that the way these ones run, this is 0, this is 90, this is 180, this is 270, this we are getting back again to 360. So basically that. Now if you're in this quadrant, what are you going to do? Okay, so if you're in that quadrant, you're going to subtract from 180. So this 45, we're also going to subtract it from 180 because that's where sine also is positive. So I'm going to say 180 minus 45. Okay, so that is like 5, this is 7. Okay, so I'm going to have 135. So basically this. So these are the 2 answers that we like have. Okay, so those are the 2 answers that we have. Okay, now that we found our answers, we just need now to convert them to you know, the actual forms. 1 2 3 4 5 6. Okay, now that we found our answers, so we've got 0 and 80. Okay, so we've got 0, comma, we've got pi, we've got 45. Okay, 45 is just the same as that is 1 over 4 pi. A quarter of 180 is like 45. Then 135, what is it going to be? So we're going to have what? 3/4 of 180. Okay, that will be like 135. Then we're going to have pi, which is 180. So basically that, so these are the answers that we are going to have. Now, are there answers that are between, let's say, okay, so these are the positive answers that we found. Now don't forget that we also had, we're saying this is positive or minus, okay, because we have to find the square root. Okay, so we were finding the square root of 1 over 2, and we said it is positive or minus 1 over root 2. Okay, basically that we found it for positive 45. What about for negative 45? Okay, so that, so let's also include those ones for negative 45. So now, where is sign in negatives? That's the question. So all students take coffee. Okay, so in this quadrant, sign is in this only in this quadrant is sign positive. So it means in the third quadrant, so this is 270, this is 360, this is 90, this is 180. So if it's in this range, we're supposed to find that. If it's in that range, we're also supposed to find that. So for us to find this region, and this region, because that's where it's negative. So in this case, we are saying, since it's 45, now in this case we're saying negative 45. So we're going to add that 45 to 180 to find in the third quadrant. That's how we find in the third quadrant. So we're going to have 180 plus 45. Then to find in this region, we're going to subtract that 45 from 360. So 360 minus 45. So basically that's what we're going to do. Now if I add 180 plus 45, that is like 5, that is like 12, that is like 225. Then when I subtract this side, I'm going to like 5, this is like 5, this is like 1, this is like yeah, 315. So basically even these ones are valid answers because they are below 360. So it means our solution is supposed to have 6 answers. So if you just write this first 4, you're not going to get the 4 answers, 4 marks. So we're supposed to also convert 225 to pi and 315 to pi. Basically we learned about how you convert those ones. Okay, we know that 225, the way you convert it, it will just be 180 over pi. Same with 315, so it will be 315 multiplied by pi over 180. So basically that. So just supposed to like divide and, you know, solve those ones. Okay, so how do we now solve these ones? So you look for numbers that can divide into both, so that you just, you know, simplify it further. Which one can we like, which one can be the best that we can pick? Okay, so let me just use a different color so that as we are solving, it becomes easier for us. Let's say, okay, let's start with 3 and 218, that is 60, and 180, that is 360 is 60. 3 into 21 1, that is like 7, remainder 1. 3 into 15, that is like 5. Okay, another number that you can do, even the same 3 again, 3 into 6, that is like 20. Okay, that is like 20. Then when you come to the other side, 3 into 7, that is like 2. Then into 5, 15, that is like 5, 25. Okay, basically you've seen where we're going. So now we're just going to divide by 5. So 5 into 20, that is like 4. 5 into 25, that is like 5. So another solution that we have is 5 pi over 4. Okay, now let's come to the other side. So basically you don't have a calculator in the exam, so you're just supposed to be doing this manually. So when you come to the other side, we've got okay, so we're going to do the same. So 3 into here, into this one, let me just use the same color that we are using, red. So 3 into this is giving us 60. When we say 3 into 3, that is like 1. 3 into 1, that is 0. 3 into 15, that is like 5. Okay, another number, let's say 5. 5 into 60, 5 into 6, that is 1. 5 into 10, that is like 12. Okay, 5 into 10, that is like 2. 5 into 5, that is like 1. Okay, 3 now can achieve it. So 3 into 12, that is like 4. 3 into 21, that is like 7. So basically we have 7 pi over 4. So basically these are all the solutions that they want. All the 6 solutions are valid because they're in the range from 0 to 2 pi. 2 pi, that is like 360. So basically this is how we solve this question. Okay, so we have a question on calculus. We're told to find dy dx given that y is equals to that. Okay, so questions on calculus are not very much complicated because they are straightforward. Okay, so for us to solve this one, I'm going to use the product rule. Basically that is it, because we've got this and the sine x and they're multiplying. So basically that. So this is a product rule. So in the exam, show them I'm using product rule to show them that you know what you're doing. Okay, so we are using product rule. Okay, so what are we going to do now? You know that when you're using product rule, dy dx, this just you're differentiating y with respect to x. That's what it means. So this will be equals to it's going to be equals to, in this case, if I'm going to have v and u, okay, if I'm going to name our, because we've got two functions that are multiplying, so in this case I'm going to get first my v, then I differentiate u, so du dx, that is a product rule, plus I'm going to get my u, then I'm going to differentiate the v, so I'm going to have dv dx. So this is how you use the product rule. Okay, now we can let what we want to be v and what we want to be u. So we're going to let our v to be equals to the square root of x squared minus 1. Okay, now this I can simplify it further to be, you know that the square root is just the same as, this would be x squared minus 1. The square root is the same as a half. Okay, so allow me to write it nicely, half. So that is what I have. Then my u, we're going to say u will be sine, so u will be sine x. So we're going to let u to be equals to sine x. So basically that is what we have. So let's start solving now. We've got v is the square root, so I'm going to write it the square root of x squared minus 1. Then we're going to differentiate u. We've said is sine x. Now sine x, how do you differentiate sine x? When you're differentiating trigonometric function, you have to remember this diagram. It is always a guide, okay? So take this x-axis, this will be sine, this will be cos, this will be negative sine, this will be negative cos. Okay, basically that. Now you're going to be moving anti-clockwise. Anti-clockwise, you're going in that direction. It means you're differentiating. However, if you are integrating, it's the opposite. If you're integrating, you're going to be moving clockwise, okay? However, since we're differentiating, you're going to be moving clockwise. When you differentiate sine, it's going to give you cos. When you differentiate cos, it's going to give you negative sine. When you differentiate negative sine, it gives you negative cos. When you differentiate negative cos, it's going to give you sine. So that's what it means, okay? So in this case, when you differentiate sine, it's going to give us our cos. So even in this case, since we're differentiating u, so when you differentiate sine x, what are we going to have? We're going to have cos x. So here I'm going to have cos x plus, okay? I come to u. U we've said is sine x, so I'm going to write it. This is sine x. Then I differentiate the other one. What am I differentiating? I'm differentiating v. V is that. So let's differentiate that. Okay, now if we differentiate this, what are we going to have? Now look at, since after we simplified it like that, it becomes a power rule, okay? So differentiating that using now the power rule, okay, because it has a power of half for the power rule. So you have to know all these rules, very, very important. Now according to the power rule, so how are we going to differentiate that? So we're going to get the power, multiply it with the coefficient, then to the power we're going to subtract 1, then we're going to differentiate this. Okay, so we're going to have half multiplying by x squared minus 1. So that is what we're going to have. Then to the power we're going to subtract a 1. Now the power is 1 over 2. 1 over 2 minus 1, you know that it's just going to give you negative half, okay? So basically that, so I'm going to have negative half. Okay, now that I've got that, I'm also going to differentiate what is in the bracket itself, which is x squared minus minus 1. So now if I differentiate x squared minus 1, what do I have? So 2, I'm going to have 2x to the power, I'm going to subtract the 1. 2 minus 1, that is just the 1, which I'm not going to write, minus 1. Now if you differentiate the constant, it's just 0. So therefore our answer in this case is 2x. So I'm going to multiply this by 2x. So basically that is the power rule, okay? So that is what we're going to put there where it needs to be put, okay? Or this, if you want, we can simplify it further. If you want to simplify it further, how is it going to be? Okay, how can it be? Okay, let's just try to simplify it a bit. So because we have a 2x, so this and that, the half and the 2 and 2 are going to divide, therefore I'm just going to remain with x. So I have a scenario where I have x squared minus 1, this is to the power negative half, then I've got an x, I'm multiplying by an x. Now you know what this means. We know that if I've got a power of negative x squared minus 1 to the power negative half, what this means is that I'm going to have 1 over x squared minus 1, this is to the power half, okay? Therefore, now there's an x here, this x is here is going to multiply with the 1 that is on top, okay? So if it multiplies the 1 on the top, I'm just going to have x on top. Now this simplifies to, I'm going to have x over this is the same as the square root, the one that is down is the same as the square root of x squared minus 1, basically that. So I'm going to replace it there now after differentiating. Let's now replace it where it's supposed to be put, here. So I'm going to have okay, so I'm feeling okay, let me just do it like that. The sign x I'm going to write it at the end so that we write it nicely. So allow me to just write my x over the square root of x squared minus 1. Then let me write my sin x at the end like that. So basically that is what we are having. Now if I solve now completely, what do I now have as my final answer after differentiating? I'm going to have the square root of x squared minus 1 cos x plus, I'm going to have sine x, or let me say x sine x, because they're going to multiply on top. So I'm going to have x sine x over the square root of x squared minus 1. So basically this is how you differentiate, this one. So that is how you solve question number 1. Now let's come to question number 2. We are told that let f of x is equals to that. So this is trigonometry, right? Yeah, cos that. Find the amplitude, the phase shift, and the period of the function. Then we are taught to sketch the graph of f of x. Then we are also taught to find the values of x for which f of x is equals to that. Okay, so that is the function that we've been given. So we've been given cos x, cos is equals to that. Okay, then we've been given a range. X is between 0 and 2 pi. 2 pi, that is just like 360. So what are we now going to do? So what is the amplitude? How high our graph is going to go? Okay, so in this case you're going to look at the coefficient of the cos. In this case is 1, so that is the amplitude is equals to 1. What about the phase shift? So the phase shift is the shift in the x. Now where there's x, here is 2 pi. Okay, then we've shifted it like on the other side. That's what it means. What is in the bracket will be like close to the phase shift. So that is what we are going to like have. Now we've got a 2 there, so you have to be very, very careful. So want the x to be alone, so you have to be very careful on this one. So when we've been given f of x is equals to cos 2x minus pi, so we are supposed to write it in the normal form. In this case I'm going to like just remove it. I'm going to remove the 2 outside, okay, so that we just remain with x to see how x is behaving without 2, because 2x is a double angle, right? So basically that. So I'm going to remove it. I'm going to have x outside, so this will be equate to, what am I going to have here when I remove the 2? I'm going to have pi over 2. Basically is that. Okay, now when we have this, that's when now we can find the shift in the x, because you're not finding the shift in the 2x but the shift in the x itself. So therefore the shift in this case, you're able to see that it is the coefficient, or in this case it's the same, negative pi over 2, or half then pi. Okay, the same last part, that is the phase shift. Okay, however, do we have a vertical shift in the y direction? We haven't been given. Okay, so basically that. Then the period is the time it takes to complete a full revolution, and the way we find the period is 2 pi. 2 pi is 360. A full revolution is 360 divided by b. B in this case is the coefficient of of x. Now initially you have to see that the coefficient of x in this case is 2. Okay, so that will be b, so it will be 2 pi over 2, and 2 and 2 can divide, therefore I'm just going to have pi, so that will be the period. So basically these are the answers that we have for the period, for the amplitude, you know, and for the phase shift. Okay, that. So allow me to rub this part. So we can write the amplitude, which I'm just going to abbreviate as A, it's 1. The phase shift, which I'm just going to abbreviate as PS, it is what is it? It is 1 over 2 pi. Then the period, which is the time, in this case we found that it is pi 180. Okay, that is what we have. Okay, so the first shift is, you're just getting how you've shifted to the x, you've shifted it negative half pi, or you've shifted half pi to the negative side. So that's why I haven't put the negative. Basically this is what we have. Now we've got everything we need to sketch the second question, which is we're trying to sketch the function. So if I'm going to write, this is my y-axis, this is my x-axis. So how are we now going to sketch this one? So let's start with the what? So the amplitude is 1, so this graph is going to be tension between 1 and negative 1. Then this will be 0. Okay, now if you look at the function itself, it is yeah, it's positive. So you know that the what do I want to say? The cosine graph usually starts from here and it goes like that and it goes like that. Okay, that is a positive one. A negative one, or it starts this side, goes like that. Okay, so basically that. Now let's put the period. We are saying the period is supposed to end in terms of pi. So in this case, if I'm going to put my pi there, okay, then half of pi, I'm going to have half pi. Okay, the half of this, I'm going to have quarter pi. For me to find the one that is on the middle, I'm just going to multiply this by 3. Quarter by 3, I'm going to have 3 quarters, or 3 over 3 pi over 4. That is what I have. Okay, now what am I going to like have? So if we look, the pi that we've been given is negative, so in this case our graph is going to move past these points. From this point it goes like that, goes there, passes there, and passes there. So therefore it's going to move something like that, passes through there. Okay, not really drawn to scale. Okay, it passes through all these points. Okay, okay, that is like our graph. Now we've been told to find the values of x for which f of x is equals to that. Okay, so how are we going to solve this one? So we are saying f of x is equals to the square root of 3 over 2. So now f of x, we know we've been given that is cos 2x minus pi. So we're saying this is equals to the square root of 3 over 2. Now if this is what we have, what is square root of 3 over 2 in terms of angles, and this is cos, so basically that is an angle. Okay, so how are we going to do this? We're going to have 2x minus pi cos inverse of square root of 3 over 2. So we're going to have 2x minus pi is equals to, now pi over that is like cos, that is like cos the square root of 3 over 2. You know that is a 30 degrees. Okay, that is a 30 degrees. But now in terms of pi, because we've been given a range of pi, so you have to make sure that all your answers are in terms of pi. Now 30 is just the same as that is 360 divided by 6. That's the one that gives us 30. So that is pi over 3. Okay, now 30 is positive. So if we're going to go to our all students take coffee, so where else is cos positive? We're able to see that in the third quadrant cos is also positive. So we found that in this quadrant is 30. We also have to find in the other quadrant. So we're going to subtract from 360. So 360 minus 30, that gives us like 360 minus 30, that gives us, is it 330? Yeah, 330. So basically that. Okay, so that is what we have. Okay, so what are the two answers that we are going to have? So now 330 in terms of pi, you also have to make sure that you convert it in terms of pi. So 330 multiplied by pi over 180. So the zeros can cancel. 3 into 3, that is 11. 3 into 33, that is 11. 3 into 18, that is 6. So this is like 11 pi over so another answer that we have will be 2 x minus pi is equals to 11 pi over 6. So these are the two answers that we have. Now we have to now solve. Okay, okay, solving the first one, I'm going to have 2x will be equals to pi over 60. When I take the pi to the other side, it becomes positive pi, right? So I'm going to have positive pi. Then when I also solve the other one, I'm going to have 2x will be equals to 11 pi over 60 plus pi. Okay, so basically this is what I have. So what do I now do? I can now solve. So I can divide this side. I can find the common denominator. The common denominator is 6. 6 into 6 is 1. 1 multiplied by pi is pi, plus 1 into 6 is 6. 6 multiplied by pi, I'm going to have 6 pi. Therefore, if I'm going to continue with this one, I'm going to have, this is 2x, this is 2x. So pi multiply pi plus 6 pi, that is 7 pi over 6. Okay, that is what I have. So for me to remain with my x, allow me to multiply by 1 over 2 on both sides, 1 over 2 even on the other side, so that the 2 and the 2 divide. Therefore my x as a value, because we're trying to find the values of x, so my x as a value will be 7 pi over 6 multiplied by 2, that is 12. So that is one value of x. Let's come to the other side. So I'm going to have 2x because to, let's also find the common denominator this side, which is 6. 6 into 6, that is 1. 6, 1, then I'm going to have 11 pi plus, there I'm going to have 6 pi. Okay, so 2x is equals to 11 pi plus 6 pi, that is like 17 pi over 6. For me to remain with x on the other side, I'm also going to multiply by half on this side, also half on the other side. So the 2 and the 2 are going to cancel, therefore my x is going to be 17 pi over 12. So basically these are the two answers that I'm going to have for this one. Okay, basically let's solve the last two questions as we are taking a break on this exam paper. Okay, so let's start with the first one. We've got A union B intersection A union B. There's a complement on B. A union B complement. Okay, so basically, is this a distributive law? Of course. So therefore I'm going to have A, according to the distributive law, you know that initially you know that it was A union B intersection B complement. Okay, because what this means is just like you know that union mostly signifies something like a multiplication. Your intersection usually signifies something like a positive, a plus. So what it means is that I've got A, I'm multiplying by B plus B complement. That's why they were able to, now if we multiply that, that's why they're able to have A this side and also A on the other side. So that is what it meant. Okay, now that we've got that, what does that mean now? So we have to find what B intersection B complement is. So now if I'm going to get B, what is common between B and B complement? If this is our B, okay, so therefore B complement will be outside, right? Now the question would be, what is the intersection between B and its complement? You're about to see that there's nothing that is common. Okay, so what is common between something and nothing? There's nothing common between something and nothing, right? So basically this will give us an empty set. So I'm going to have A union empty set. So now the question will be, now what is when you combine something with nothing, because an empty set there is nothing. Okay, so when you combine something with nothing, what do you get? You're just going to get something, right? In this case you're just going to get A. So basically this is how you're going to simplify this one. Okay, now let's come to the last one. So we've got A complement. Okay, this is a big set union A intersection B. They have a complement outside and we have a complement outside again. So basically this is what we call the De Morgan's laws. Okay, so to understand this law, even in in details and practice questions, you can just type the De Morgan's laws Novastone Academy. You're going to find a full video explaining on that. So basically, how are we going to, according to De Morgan's law, if I've got A union B, then I've got a complement outside. When the complement is outside, it's going to distribute inside. So therefore this will give me, the complement is going to fall on A. I'm going to have A complement. It's going to fall on the operation, which is the union. In this case it's going to change to intersection. I'm going to have intersection. Then when it falls on B, I'm going to have B complement. That is the De Morgan's laws. So it's going to fall on two sets. So basically that's what we're going to do also to this part. So now what are we going to, we've got two sets, this one and this one. Okay, so when it falls on the first set, we are going to have we have a complement. We already have a complement, and the complement and the complement, they cancel out. So I'm going to just have A. Then when it comes to the operation in this case is union, it's going to change to intersection. Then when I come to the other side, this is the other side that we are coming to now. That is, it has a complement outside. So the complement and the complement are going to cancel as well. So I'm just going to remain with A intersection B. Okay, so now someone can ask, is multiplication let me say, is addition commutative? Of course, addition is commutative provided you are maintaining the same number. If, let me say, A is 2, let's say A is 2 and B is let me say B is 1. So if I say 1 plus 1 plus 2, am I going to get the same answer if I say if I say 1 plus 1 plus 2? Okay, basically that. Let's start the first one. 1 plus 1 plus 2, that is 3. 3 plus 1, that is like a 4. When I come to the other side, 1 plus 1 is 2. 2 plus 2, that is like a 4 as well. So basically that's what we're also going to do. Okay, so we're getting the same answer. So even in this case, like I've said, intersection, always in your mind, always think it is the same as a plus. Okay, basically that it helps you to analyze things. So therefore, what are we going to do now? I'm going to have A intersection A. I can also put it in brackets, intersection B. It doesn't change anything because you said addition is commutative. Okay, now that we've done that, let's find the the intersection between A and A. Now, what will be if this is our A? What is common between A and A? Or what is common between U and U? It's U, right? So basically the intersection of A and A is just A. So I'm going to have A intersection B as my final answer. Basically this is how you simplify these sets. So now that we've solved these other parts, for you to access the full solutions, you can register with us and you're going to access all the solutions for the rest of the questions, a video explaining all these other questions. So basically we're going to end from here. Thank you for watching, and don't forget to subscribe to our channel. See you in other and later sessions.